Hi, welcome back to Science 1206, the Chemical Reactions Unit. I'm Ms. Ledwell, and in this video, we'll continue our discussion of everyday chemistry. Let's get started. What role does chemistry play in cosmetics and hygiene products? Have you ever taken a moment to examine the ingredients listed on cosmetics like lipstick or personal hygiene items such as antiperspirants? If you have, you may have come across terms like aluminum or zirconium-based compounds listed on the label of your antiperspirant products. These chemical compounds play a crucial role in antiperspirants by physically preventing sweat from escaping your sweat glands. Lipsticks are formulated with pigments to provide vibrant colors and a blend of natural or synthetic oils to ensure smooth application and lip hydration. The specific composition of lipsticks will vary depending on the brand and type, encompassing a wide variety of chemical compounds. Examining the ingredients in everyday cosmetics and personal care products offers insight into the chemistry that contributes to their effectiveness and uniqueness. The cosmetics industry depends upon a knowledge of chemistry to create effective products while ensuring user satisfaction and comfort. Now let's take a look at the role of chemistry in batteries and electronics. Batteries and electronic devices like smartphones contain various chemicals and may include elements from the periodic table, such as silicon, lead, nickel, and lithium. Understanding the chemistry behind these devices helps us appreciate the technology we rely on daily. The image below of the periodic table highlights some of the elements that are used in batteries, such as lithium, sodium, potassium, magnesium, calcium, and many others. Did you know that chemistry also plays a role in our food? Have you ever wondered what's really in the food you eat? If you have ever read the ingredients list on items in your refrigerator, you might have noticed that naturally derived or synthetic chemicals make up all of our food. For example, glycerol, also known as glycerin, which has the chemical formula C3H8O3, is commonly found in various food products. In candy production, glycerol plays a role in preventing sugar from crystallizing. Some bakery items may have glycerol added as an ingredient to maintain their moisture and prevent dryness. Have you ever been enchanted by the brilliantly colored cakes and cupcakes in the bakery shop's window? I know I have. Color is often added to different types of food to enhance its visual appeal. Sometimes natural substances like chlorophyll, with its chemical formula C55H72MgN4O5, are used to add color. Chlorophyll may be added to give food a green color. Food manufacturers may also choose synthetic food colorings for their products due to their stability, prolonged shelf life, and cost effectiveness. An example of a common artificial color is Allura Red, also known as Red No. 40, with the chemical formula C18H14N2Na2O8S2. Chemistry also plays a role in fuels and transportation. Fuels and various modes of transportation also rely on chemicals and chemical reactions. Fuels for vehicles, like gasoline used in many cars, are made from refining crude oil, a fossil fuel formed from the remains of dead plants and animals. Crude oil is a mixture of hydrocarbons, which are molecules composed of only hydrogen and carbon atoms. Other chemicals are added to the gasoline, for example, certain chemicals that help reduce the emissions of greenhouse gases. A type of chemical reaction called combustion, which we'll talk about a little later in this unit, occurs in a car's engine when gasoline and air mix together and are ignited by a spark. This combustion reaction produces carbon dioxide gas, CO2, and water, H2O. Heat energy is released from the fuel and is converted to mechanical energy in the engine. Mechanical energy is used to move parts of the car, like the wheels. Now it's time to continue to the next video. Before you do, take a moment to pause, stretch, and prepare yourself to dive back into exploring chemistry.